970 Part B. Hydrogen gas can be prepared from the reaction of zinc metal with hydrochloric acid. And we're looking at Part B only. How many grams of zinc would you start with if you wanted to prepare 6.35 liters of hydrogen at a pressure of 292 millimeters of mercury and 229 degrees Celsius? All these stoichiometric gas problems all involve the same gag. What they're going to do is they're going to have you use Pivnert and run moles in and out of it. So let's take a look here. If we look at what they gave us a volume of hydrogen at 6.35 liters. They gave us a pressure of hydrogen at 292 millimeters of mercury. And they gave us a temperature. Why in the world? What is wrong with these people? Why in the face of the planet do they keep using Celsius? I mean, really, what in the world did I ever do to them? Did I forget their birthday or something? Seriously. So we're going to convert that right away to Kelvin. Now, we know we're going to be using Pivnert. So, since we know we're going to be using Pivnert, we are going to have to do a quick conversion from millimeters of mercury to ATM. But at least it's a legit temp scale. So, we've got 292 divided by 760 gives us a pressure of 0.3842 ATM. So now it's a matter of setting up Pivnert. PV equals nRT. So we've got 0.3842 ATM times our volume, 635 liters, equals number of moles we're going to solve for times our gas constant. And I'm going to admit, well, liters, ATM, moles, Kelvin. Last time I'm going to write the units for the gas constant for this problem because it makes my work really super messy. 302.65 Kelvin. So now it's a matter of algebra. I'm wanting to get my number of moles all by itself, so I'm going to divide both sides by my gas constant and my temperature. And that's going to give me 0.3842 ATM times 6.35 liters divided by 0.0821 divided by 302.65 Kelvin, and that gives me my number of moles. Zero 0.09819 moles. That's only half the battle. This is my moles of hydrogen, and they're wanting grams of zinc. This is where we now revert to traditional stoichiometry. I should have game planned this from the beginning. Nearly all these problems involve taking Pivnert solving for your number of moles, and feeding that number of moles into a traditional reaction stoichiometry situation, or involves taking the product of reaction stoichiometry and feeding it into PivNert. It always is one of those two methods. In this case, we're using to solve for our number of moles, and we're going into the reaction. So we have our number of moles, and now we're going to need to use our reaction and go with our traditional stoichiometry. So let's blow that up again. There's our chemical equation. There's our number of moles. That's 0.98 moles of hydrogen. And they want grams of zinc. So we're going to go 0.09819 moles of hydrogen. I don't want moles of hydrogen, according to my chemical equation. For every 1 mole of hydrogen, I require 1 mole of zinc. And then I go to my periodic chart, and for every 1 mole of zinc, remember I'm placing units where they cancel out. Hopefully I have a periodic chart document. Come on. Periodic chart. Axio periodic chart. All right. According to the periodic chart, the molar mass of zinc is 65.38 grams zinc. Multiply everything on top, divide through everything on the bottom, which basically means 0.0981 times 65.38. And that gives me, wow, that gives me 6.42 grams of zinc.